Today we will be talking about the periodic table.
When looking at an empty periodic table, it can be compared to a castle. It has a main wall, and it has tall, defensive turrets on both sides. The castle has 18 columns, called groups, and 7 rows, called periods, with what would normally be considered a landing strip of 2 rows beneath it. Each box or brick normally would contain an element, which is a chemical substance that cannot be broken down into a simpler form. Now let's talk about these periods and groups. Every atom of an element is surrounded with a different number of shells. All of the elements in a period have the same number of shells for their electrons. For example, chlorine has 3 shells for its electrons. Therefore, chlorine has to be in the 3rd period of the periodic table. In a group, all of the elements have the same number of valence electrons, with some exceptions to the transition metals. Valence electrons are the electrons in an atom's outer shell. In groups 13 through 18, you would remove the first digit, leaving you with the numbers 3 through 8. This would be the amount of your valence electrons. Now let's look at an example. Krypton can be found in group 18 of the periodic table. We will take off the first digit of the group number, leaving us with the number 8. This tells us that krypton has 8 valence electrons. If we return to the castle idea, it should be noted that the bricks of the castle cannot just be moved around. If one of these elements was sitting in a different spot, the whole castle would fall to the ground. Elements are not exactly like bricks. They are not all the same. Each element has its own unique properties and therefore has a specific spot in the periodic table. Let's look more into the elements. Within a box, the symbol for a specific element is in the center. Directly under the element symbol, the element's name is written. On top of the box, there is a number known as the atomic number. This number tells how many protons are found in the nucleus, or center of an atom, and how many electrons are circling the atom's nucleus. Finally, there is a number at the bottom of the box. This number is known as the atomic mass. This is the total weight of the entire atom. The periodic table also separates the elements into 10 different families. These families are alkaline metals, alkaline earth metals, transition metals, metalloids or semi-metals, nonmetals, basic metals, halogens, noble gases, lanthanides, and actinides. These elements are all grouped together because they share some specific characteristics. For instance, the noble gases are all able to conduct electricity, and they are odorless and colorless. Now you may be asking yourself, how does this relate to what we are doing in class? Well, we are currently focusing on the topic of molarity. Molarity is the amount of moles per liter of water. The number of moles in a compound is determined by the combined atomic masses of each atom in the compound, or molar mass. The atomic mass of the elements that make up the compound can be found on the periodic table. Elements on the periodic table also have different forms called ions. Ions are formed when an element either gains an electron, giving it a negative charge, or loses an electron, giving it a positive charge. In class, we are using this knowledge of these ions to explain the bonding between different elements and compounds. In fact, these ions can directly impact your everyday life. The water that is supplied to your home can contain ions. These ions can affect the taste, color, and smell of your water. Because of this, most homeowners own a water softener, which is an appliance that helps to remove the ions from the water supply. Keep your life stable. Remember the periodic table.